Good day, Batang IS! For today, we're going to discuss the new things in math. We have the first one, which is a special product. So, what are you waiting for? Let us enjoy watching while we are learning. Good day, everyone! Now we will have the first lesson. We have the special product. So, at the end of our lesson, we will going to recall the multiplication or how to multiply polynomials. And we also use algebraic method on how to get the product of the square of a binomial, product of the conjugate pairs, square of a trinomial, cube of a binomial, and the product of a binomial and a trinomial. So, what is a special product? Okay, so there is a binomial and a trinomial that we may multiply the product and we can create a form or it can be a pattern. So that is a special product. A special product is the use of a patterns. You can be able to find the product even it is a square of binomial, product of conjugate pairs, square of trinomial, cube of binomial, and a product of binomial and trinomial with special cases. So algebra is generalized mathematical thinking based on patterns, relation between them. Okay, let us have the first one. The special product, we have the square of binomial. So mathematical like to look for a pattern that will make true work easier. So a good example of this is the square of binomial. While you can always get the product by writing the binomial twice by using the distributive or FOIL method, there is a less work to do if you learn to use pattern. So let us have this pattern. So let's start that a plus b times the quantity of a plus b. So what does it mean? So we have the quantity a plus b squared. So what is the first term in that given expression? So we have a. And the second term, we have b. So let us find the square of the first term. So a squared is equal to a squared. And then let us find the product of the two terms times 2 or twice the product of the two terms. So we have 2 times the product of a times b. So we have 2ab. And next, let us square the last term. So our last term is b. So b squared is equal to b squared. Now, let us simplify. So, the quantity of a plus b squared is equal to a squared plus 2ab plus b squared. When we have a given binomial or getting the square of a binomial, it results to a special trinomial of the specific form, and that is called perfect square trinomial. So let us have an example. Find the square of binomial using the binomial squared pattern. And here we have the quantity of x plus 3 squared. For our solution, so first let us have the first term. So what is the first term? We have x. The second term is 3. Now, let us have the square of the first term. So we have x squared. Then, twice the product of the two terms. So multiply the two terms that we have. So x times 3 times 2 is equal to 6x. And now, let us find the square of the last term. Our last term is 3. So find the square of 3. So we have 9. Then, we can have the simplify of the given answer. So, the quantity of x plus 3 squared is equal to x squared plus 6x plus 9. Another one example. We have the quantity of y minus 7 squared. So, what is the first term? We have y. The second term, we have negative 7. Don't forget the sign of the given number or expressions. So we have negative 7. Then, let us find the square root of the first term. So, y squared is equal to y squared. Then, let us find the twice the product of the two terms. So, getting the product of the two terms that we have, so y times negative 7 is equal to negative 7y times 2 is equal to negative 14y. Then, find the square root of the last term. So, we have negative 7 squared is equal to positive 49. Let us simplify. We have the quantity y minus 7 squared is equal to y squared minus 14y plus 49. Now, look at our result. Did you see any patterns? Yes, we have. So first, let us get the first term of the given binomial. Then, we're going to find is the square root of the first term. Second, to get the middle term of the product, multiply the terms and double their product. Okay? And the third one, get the last term of the given binomial, then squared the last term. So that will be the pattern in the first. For the reminders, here is the squared binomial pattern. So if a and b are all real numbers, so we have a plus b squared is equal to a squared plus 2ab plus b squared. This will be the square root of a sum. Then if we have the binomial, which is their operation is difference or minus, so we have a minus b squared, then it is equal to a squared minus 2ab plus b squared. Again, our first step, square the first term. Second step, double the product of the first term and second term. And last, squared the last term. Let us have the second one. Get the product of the conjugate pairs. So a pair of binomial that each have the same first term and the same last term, but one is sum and one is different. This is called the conjugate pair. It is in a form of a plus b and a minus b respectively. This is the same with sum and difference of two terms. There is a nice pattern for finding the product of the conjugates. You could use, or we can simplify this by the use of FOIL method. So to get the product by using the pattern, may use the work easier. So let us have the first one. So let us find the product of x plus 3 times the quantity of x minus 3. So what is the first term? So we have x. What is the second term? We have 3. Okay? So let us have the square root of the first term. So we have x squared. Square root of the second term, we have 9. Because it is 3, so square root of 3 is 9. Then we can express this difference of 2 squared by x squared minus 9. Another one, let us have another one. Y plus 7 times the quantity of y minus 7. So what is the first term? We have x. The second term, we have 7. So let us find the square root of the first term. So we have y squared. Square root of the second term, we have 49 because we have 7. So 7 squared is equal to 49. Then let us express the 2 squared by difference. So we have y squared minus 49. Okay. So what have you observed in the product that we have? So the product of the two binomial is also a binomial. Most of product resulting from FOIL have been trinomials, right? But why is there no middle term? You have noticed that the two middle terms you get from the FOIL combined is 0 in every cases. So the product of the conjugate of pairs is always of the form of a squared minus b squared. This is called the difference of squared. This can be derived from the pattern. So we have the pattern. First, this is the step. First, to get the first term of the product, square the first term. Okay? Second, to get the square of the product, square the second term. And lastly, express the difference of their squared. So that's it. So we have the difference of squareds. Okay? So the perfect square trinomial is for the product of a binomial. Then, the special form, if we have the conjugate pairs, we have the difference of squared. Okay? So let us have an example. So number one example that we have 10 minus 2 times the quantity of 10 plus 2. Okay? So our first term is 10 and the second term is 2. So first, let us get the square of the first term. So 10 squared. Then, next, find the square of the second term. So we have 2 squared. Then express the difference of their squared. So we have 100 minus 4. Then simplify. Because they are both constant, we're going to combine the two. So we have 100 minus 4 is equal to 96. You have noticed that if we have 10 minus 2, it is equal to 8. Then 10 plus 2 is equal to 12. So 8 times 12, the answer is 96. So we have the same answer. Okay? The next one. So let us have the second example. Our second example is the quantity of 6b squared plus 5q raised to the 4th power times the quantity of 6b squared minus 5q raised to the 4th power. So our first term is 6b squared and the second term is 5q raised to the 4th power. So let us find the square of the first term and the square of the second term. So square of the first terms that we have. So we have 6p squared. So 6 squared is equal to 36 and p squared. So if we have the square of the power, we're going to multiply. Okay? Rules of exponent. So 2 times 2 is equal to 4. Therefore, we have 36p raised to the 4th power. The next one, we have the square of the second term. So our second term again is 5q raised to the 4th power. Okay? So 5 squared is equal to 25. Then q raised to the 4th power squared. So multiply the exponent. So 4 times 2 is equal to 8. Therefore, we have 25q raised to the 8th power. Then express the difference of their squared. So we have the final answer, 36p raised to the 4th power minus 25q raised to the 8th power. So we have the product of conjugate patterns. Again, if we have the two real numbers, we have a and b. So we have the quantity of a plus b times the quantity of a minus b is equal to the a squared minus b squared. And here again the step. Number 1, square the first term. Number 2, square the last term. And lastly, express the difference of their squared. So next is the square of trinomial. So now let us move to trinomial. We will learn to expand the square of trinomial. We have, for example, a plus b plus c. So there is a 3 term. So it is trinomial. When we're going to square the trinomial, it is the same way how we're going to multiply the ordinary variable, ordinary number. Okay? So we're going to multiply by itself. However, unlike the other process, we're going to use the pattern. Okay? So it's better to undergo the long multiplication. So if we have the trinomial a plus b plus c, so we can get this squared of this trinomial. We have a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. So by the use of the squared pattern, okay? So just multiplying the a times a, we can get a squared. A times b, we can get ab. A times c, we can get ac. Then proceed to b. So b times a, we have ab. Then b plus b, b times b, we have b squared. And b times c, we have bc. Then proceed to c. So c times a, we have ac. C times b, we can get bc. Then c times c, we have c squared. Then add. Let us add. So we have a squared plus b squared plus c squared. Then you can define that we have 2ab, right? So we have plus 2ab. We also have 2ac. So we're going to add 2ac and plus 2bc. Okay? Have observed the following product of the square of a trinomial. So first one that we have x plus y plus z squared. So trinomial x plus y plus z. So we can have the simplify of this squared of trinomial. We have x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. Number 2, we have x trinomial x plus 2y plus 4 squared. So we have x squared plus squared of the second term 2y squared, it is equal to 4y squared, plus squared of the third term, we have 16 plus 4xy plus 8x plus 16y. The last one, we have x squared plus 3x minus 1 squared. Getting this squared of trinomial, we have x raised to the fourth power plus 9x squared plus 1 plus 6x cubed minus 2x squared minus 6x. Now, did you recognize any pattern in multiplying the square of trinomial or getting the product of a trinomial? Yes, we have. So first, to get the first, second, and third term of the product, just get the square of the first term, second term, and last term. Okay, next one. To get the fourth, fifth, and sixth term of the product, twice the product of the first and second term, first and last term, and second and last term. Did you get the pattern? Okay, so let us have an example. Number 1, we have the trinomial d plus e plus f squared. So let us find the square of the first term. We have d squared. Next, square of the second term. So we have e squared. And square of the third term, we have f squared. For the fourth terms, we have twice the product of the first and second term. So our first and second term is d and e. Multiply, then times 2. So we have d times e times 2 is equal to 2de. For the fifth term in the given, so we have to get the product of the first and third, then times 2 or double. Okay, so we're going to have the first and last. We have d and f, then times 2, so we have 2df. For the sixth term, so we're going to twice the product of the second and third term. So our second term in the given is e, and for the last term is f. So multiply the 2, then times 2. So we have e times f times 2, we have 2EF. Now, let us simplify. So, the product of the square root of a binomial DEF squared is equal to D squared plus E squared plus F squared plus 2DE plus 2DF plus 2EF. Okay? For the square root of a trinomial, again, if we have, this is a reminder for all, so we have the real number A plus B plus C, okay, squared. Then we have squared the first term, second step, squared the second term, third step, squared the third term, and the fourth step, for the fourth term, twice the product of the first and second. For the fifth step, twice the product of the first and the third term. And for the sixth term of the given square root of a trinomial, so we have twice the product of the second and third term. Okay? Then we can have the answer. Getting the product of the cube of binomial. So what happened when we multiply the binomial by itself 3 times? Okay, what do you think? Okay, so multiplying binomial by itself 3 times using distributive property get longer and longer. So it's not easy way, right? Because we multiply the 2, then the second again, we're going to multiply it. It's so long pattern. So, but there is some kind of pattern that we have developed. So, for combining or by getting the product of the cube of binomial, we need to know the pattern for the sum and cube and the difference of cubes. Okay, so let us have the first one, cube of binomial for addition. If we have the given binomial, which is a plus b cube, or getting the cube of binomial, which is sum, so we can have this pattern. So a cube plus 3a squared b plus 3ab squared plus b cube. And for the difference, we have, so a minus b cube, getting the cube of a binomial, which is indifferent. So, naka-minus po. So, if we have a minus b cube, so we can have or simplify it just a cube minus 3a squared b plus 3ab squared minus b cube. That's it. It's so complicated. Yes, it is. But it helps you for the following step that we have. For the cube of binomial, here is the step that we have. First, to get the first term of the product, cube of the first term. Just getting the cube of the first term. Second step, to get the second term of the product, plus 3, always put a plus, then 3 times the square root of the first term by the second term. So we're going to find the square root of the first term times the second term times 3. Okay? Don't forget. And third step, to get the third term of the product, plus 3 of the first term by the square root of the second term. So here in the third step, we're going to find is the square root of the second term times the first term times 3. Okay? Did you get the difference of the second term, the second step that we have, and the third term? For the second step, first, get the square root of the first term times the second term times 3. For the third step, get the square root of the second term times the first term times 3. Okay? And lastly, to get the fourth term of the product. So we just add the cube of the second term. So we can have the simplify of the cube of binomial addition, sum. Okay? How about for the cube of binomial, which is difference? So here is the first term. Get the first term of the product, then cube the first term. For the second step, get the second term of the product, then minus 3 times the square of the first term by the second term. Did you get it? Okay. And third, to get the third term of the product, plus 3 times the first term by the square of the second term. Fourth, to get the fourth term of the product, minus the cube of the second term. To digest what we have done, so let us have an example. Find the product of the cube of x plus 3. Okay, so first thing we to do is cube the first term, right? So the first term in the given is x, so let us cube the first term. Next one, plus 3 times the square of the first by the second term. So 3 times the square of the second term, which is x, so x squared, times the second term, which is 3. So we can get 3x squared times 3, which is equal to 9x squared. Next one, plus 3 times the first term by square of the second term. So we have 3 times the first term, which is x, times the square of the second term. We have 3 squared is equal to 9. So 9 times 3 is equal to 27, times x is 27x. Then, for the fourth term, so we have plus cube the last term. Our last term is 3, therefore finding the cube of 3, which is equal to 27, then we have the final answer. So the cube of x plus 3 is equal to x cubed plus 9x squared plus 27x plus 27. Second one, we have 3x minus 5 cube. Getting the cube of the difference. So let us have the cube of the first term. So our first term is 3x. So cube of 3x is equal to 27x cubed. Then minus 3 times the square of the first term and the second term. So we have 3 times the square of the first term. So first term natin is 3x squared. So it is equal to 9x squared times 3 is equal to 27. Then times the second term is 5. We have 135x squared. Then for the third term of the product, so we have plus 3 times the first term by the square of the second term. So 3 times the first term, 3x, times the square of the second term. So 5 squared is equal to 25, times 3 is 75, times 3x is equal to 225x. Next, cube the last term. Then take note, it is minus. So minus cube the last term. So we have 5 cube is equal to 125. Then 125 then our final answer for the cube of 3x minus 5 is equal to 27x cubed minus 135x squared plus 225x minus 125. This will be the reminder for all of you in how to have the special form in combining or finding the product of the cube of binomial. For example, we have the real number a and b. So if we have the cube of binomial, which is in sum, so we have a plus b cube, you have noticed that all terms that we have is all positive, okay? Then in the cube of binomial, which is we have the difference, so we have a minus b cube, you can notice that it is alternate of the sign. We have positive, negative, positive, negative. Okay? So, again, this is the step in finding the cube of binomial. First, cube the first term. Second step, trace the product of the squared of the first term and the second term. Third, trace the product of the first term and the squared of the second term. Fourth, cube the second term. For the cube of binomial difference, the sign of the second and the fourth term are always negative. Okay? Don't forget for that. Here we are the last part of the special product. We have the product of binomial and the trinomial in the special form. So another very interesting for us in the special product is the multiplication of the binomial and the trinomial. Okay? So let us have analyze the condition below. So first one, if we have the quantity of a plus b times the quantity of a trinomial a squared minus ab plus b squared. So we can get a cube plus b cube. Okay. For the given, you have observed that the binomial has a plus sign. Then, the middle term in the trinomial has minus sign, right? So the trinomial also has the square of the two terms, a squared and b squared. So, in the product of the sign separating the two cubes is the same to the sign of the separate of the binomial factor. Okay, next one. Number 2, let us observe. We have a minus b times the trinomial a squared plus ab plus b squared is equal to a cube minus b cube. Okay. For your observation that we have a binomial which is in minus sign. Then the middle term of the trinomial has plus sign. So the trinomial also has the square of the two terms. We have a squared and b squared. So you have noticed that in the product of the sign separating the two cubes is the same to the sign of the separate of the binomial factor. Okay, so here, if we're going to find the product of the binomial and trinomial in a special form, we're going to copy the sign of the given binomial. So the product of binomial and trinomial in a special form, we can have the sum of two cubes or it can be difference of two cubes. So let us have understand this more. So let us have example. Number 1 example we have. Number 1 examples. So we have the binomial 3a plus 4 times the quantity of a trinomial 9a squared minus 12a plus 16. So let us focus in the binomial that we have. We have 3a plus 4. So just finding the cube of the first term, we have 3a cube, then plus the cube of the second term. So our second term is 4, right? So cube of the second term, so we have 64. Therefore, in simplifying the binomial 3a plus 4 times the trinomial 9a squared minus 12a plus 16 is equal to 27a cubed plus 64. So for the reminders that we have, here is how to get the product of the binomial and a trinomial in a special form. So if we have a real number a and b, so we have a times b times the trinomial a squared minus ab plus b squared is equal to a cube plus b cube. Then in second, if we have a minus b times the trinomial a squared plus ab plus b squared, it is always equal to a cube minus b cube. And here is the step number 1. Cube the first term of the binomial factor. Number 2, cube the second term of the binomial factor. And third, separate the cube by the sign that separate the term of the binomial factor. Take note, if what is the sign of the binomial, just copy. Okay? So the algebraic product on this lesson are most used all the time. A lot in mathematics. So we have knowing across in coming chapters. They are there. They are special because they are very common and they are worth knowing. If you can recognize this product easily, it makes your life easier later on. Okay? So let us recognize and let us always know the special product that we have, because if we know them, we can easier for the next chapter. Okay? Okay, did you learn something? If you learned something, let us have this activity. I hope you answer this activity. We are done, Batang IS. I hope you learn and you enjoy while watching this video. Thank you. Goodbye. Again, I am Miss Maymar F. Galan, your teacher in Mathematics 8.